So hey everyone, welcome back to the channel. Hope you all are doing well. This is Abhishek on the other side. If you haven't subscribed to my channel, do subscribe to my channel and press the bell icon in order to get the latest notification first. So without much further ado, let's start our today's video. So today we are going to solve valid parenthesis. Now it is an easy level question from Leetcode. Now what does this question states? So in the given question we are given a string, and the valid characters for these strings are these six characters. That is, one is the opening round bracket, closing round bracket, opening curly bracket, closing curly bracket, opening square bracket, and closing square bracket. Now these are the valid characters for this string. Now what you need to do is that we need to check whether this string is a valid one or not. Now there are two conditions for to check whether the string is a valid string or not. The first one is the open bracket must be closed by the same type of bracket. Now what does this mean? Suppose we have an opening round bracket now. Now this opening round bracket can only be closed by a closing round bracket, right? And then only it will be valid. So let's say that we have an opening round bracket and it is closed by some square bracket, right? And then in this situation it will be invalid, and hence this is what this line is saying. Now it may also happen that the opening brackets must be closed in the correct order. Now what does this mean? Suppose we have a opening round bracket, then we have a square bracket, right? Now this square bracket should be closed first, right? And then this opening round bracket should be closed, okay, and then only it will be valid. It's but if there is a string like we have a opening round bracket and a square bracket, and then we have closed the round bracket at first, then we have closed the square bracket. In such situation it will be invalid because the order is not maintained, right? Because we can see that the opening round bracket is closed before then the square bracket, right? And hence this string is invalid. Now let's see some example. So here in this case we have a opening round bracket and a opening close bracket, and so it is a valid string because this round bracket is has a subsequent closing bracket, right? Now for this example also you can see that we have a round bracket, then a square, then a closing round bracket, and then a square bracket, then a closing square bracket, then a curly bracket, and finally we have a closing curly bracket. Now for each of these brackets we can see it has the, for each of the opening bracket it has a subsequent closing bracket, and hence this is also true. And now let's see for others. And now we can see for this example. So for this example we have a opening bracket and then we have a square bracket. Now in this case it will be invalid because the first condition will not be satisfied, right? Which says that if for each opening bracket it should it should have the same closing bracket, right? And so for this round bracket, in the closing subsequent closing bracket will be the round bracket only, right? Such that they are of the same type, but it is a square bracket and it is a round bracket, so it is of different type, and hence it is invalid. Now this one, for this example you can see we have a opening round bracket and have a square bracket, and then we have a closing round bracket, and finally we have a square bracket. Now in this case we find that the order is not maintained because we have a round bracket, right? And then we have a square bracket, and then we have a round bracket, so the order is not maintained. Now this square bracket should be closed first, then the round bracket, and then only it will be valid, right? And hence this is also invalid. Now let's understand the algorithm for this problem. So let's consider a string, okay? So let's say that we have a string S, which contains string as At first we have a opening round bracket, then we have a closing round bracket, and after that another we have a closing round bracket, right? Now this round bracket, for this string, this round bracket has a subsequent closing bracket, right? But this character over here doesn't has any subsequent opening bracket, and hence it is invalid, right? Now let's take another string. So let's take a string as so let's take a opening round bracket, then we have a curly bracket, and then we have a square opening square bracket, then we have a square bracket closing square bracket, then closing curly bracket, and finally we have a closing round bracket. Now now this string is a valid one because we can see that for this opening round bracket we have a subsequent round bracket, for this opening curly bracket we have a subsequent curly bracket, for this opening square bracket we have a subsequent square bracket, and the order is also maintained. Now through these two examples we have actually see a pattern. Now what is the pattern? The pattern is that the the bracket which is opened last, okay, so you if you consider this, right, needs to be closed first, right? So that means if you consider this, you can say that first this is first we found a opening bracket, right, and next we found another opening bracket, and then we have found a square bracket, right? now now this square bracket, now these are the three opening brackets we have, right, and there is no closing bracket in between them, right? so so we need to first get the closing bracket for this square bracket, right? So what you can do is that we can have a stack, right? Because because stack follows the principle of LIFO, right? I have already told you in my previous videos. Text that means the character which will be pushed or inserted first will be popped out last, or the character which is going to pushed or inserted last will be popped out first, right? So since so let's have a pointer I, okay, which we currently pointing to this bracket, that is the round bracket, right? Now since this is pointing to this, so now since this is a opening bracket, right, so we need to push it into a stack. So let's push it into a stack, then we're going to move our pointer I to this index, that's index 1, and again we found a opening bracket, right, and hence again we are going to perform the same task, right? Insert it. Now again we are going to increment our I. Now the I will be pointed to the opening square bracket. Again we are going to insert it in our stack. Now stack has only one opening, that is the top, right, and hence the element which will be popped out first will be the opening square bracket, right? Now let's increment our I again. So if we increment our I, so we have found a opening close bracket, right? So if we increment our I, so we have found a close bracket, close square bracket, right? Now when we find a square bracket, close bracket, now we need to check that our top of our stack has the closed square bracket or not, right? That means that since since we have found a closed square bracket, right, so its subsequent opening bracket will be a open square bracket, right? So we need to check that whether this whether our top of our stack contains the contains the open square bracket or not. Now we found that our top of our stack contains the open square bracket, right, and hence if we find that it is containing a open square bracket, then we're gonna pop this out from our stack. Now after popping, again we're going to increment our I. Now I will be pointing to this character, that is the closing curly bracket. Now again we're going to check, now since it is a closing bracket, so we're going to check whether this whether the top of a stack contains a opening curly bracket or not. Now we found that it contains the opening curly bracket, right? So since it contains opening curly bracket, so we're going to pop this out. from the stack. Now again we are going to increment our I, right? Now again we're going to check whether this opening, sorry, whether this now this is a closing bracket, right? Again, so we're going to check whether our top our now currently our top our of the stack is this, right? Because we have only one element left. So we need to check whether it contains a opening round bracket or not. Now since there is a opening round bracket, so this is also valid. So we're going to pop this out. Now again we're going to increment our I. Now we found we have already reached to the end of the string. So we are going to come out of the loop, right? Now after coming out of the loop, we're going to check whether our stack is empty or not. Now we can see that stack is empty because we have popped each and every element present in our stack, right? And hence it is a valid. Now let's try to implement this concept or algorithm in this string. Okay, so over here we have, so let's take a stack, right? So currently our I is pointing to this character over here, that is this character, right? That is opening round bracket. Now since it is opening bracket, so we're gonna push this to our stack. Again we're gonna increment our I. Now I will currently pointing to closing round bracket. Now since it's a closing, we need to check whether it has subsequent. So we need to check whether the top of our stack has a subsequent opening bracket or not. So it has, right? So we are going to pop this out. Now again we are going to increment our I. Now it is a closing bracket, right? But our stack is empty currently. So if we found a closing bracket and our stack is empty, in that case we need to give an invalid sign, right? Because this character over here doesn't has a subsequent closing bracket, and hence it is empty. Now let's look into some corner cases. So let's say that we have a string, okay, which contains only one opening bracket. Now if it contains only one opening bracket, right, so this opening bracket will be somewhere pushed into the stack, right? And so coming out of a loop, we would be checking whether our stack is empty or not. Here in this case our stack is not empty, and hence it will return an invalid string. Okay, now next thing, there may be also a string which contains one closing bracket, right? So if we find a closing bracket, so we'd be having a stack which will be empty, right? Now if we find a closing bracket and the stack is empty, in that case also we are gonna print, or we're gonna return invalid, right? And just for this example we have seen, right? So let's say that we have a string s, right, which contains a string as, so let's say that we have a opening round bracket and then we have a square bracket, right? Now let's see see whether this string is valid or not, right? So what you can do for that, we are again we will be having a stack, right? Now since this is a opening bracket, so it will be pushed into our stack, right? Now then we will increment our I. Now our I will be pointing to this closing bracket. Now since it is a closing bracket, we need to check whether the top of the stack, okay, contains the opening square bracket or not. Now find that in the stack we don't have a we don't have a opening square bracket, right? And hence we can conclude that this is invalid. Now let's see the code for this algorithm. So at first we need to create a stack. So let's create a stack at first. So now this is should be of character data type, right? Since we are dealing with characters over here. Now we need to check. Now actually we need to traverse through this string, right? So let's consider a string length. So let's take str length as str, or here we have the string, right? S dot length. And then let's go up to this str length and then increment it by 1. Now we are actually traversing through this string, right? Now Now we need to check whether the given character is opening. So let's first check whether it is an opening bracket or not. So for that we'll be having a function. So let's create a function bool, and let's write it as like bool open brackets, right? Okay, that is open bracket or not, right? So that will be better name. Now let's pass the character. Okay, now if this character is a opening curly bracket, right, or the character is opening, sorry, this is a round bracket, opening curly bracket, and let's say it to be a opening square bracket, right? Now if either of these three condition is true, then we're gonna return true, else we're gonna return false, right? Now we need to pass this function over here. So open is open bracket, right? Then we have to pass the character, that is s of I, right? If it is true, then it will be going inside this. Now we have to push this opening bracket into a stack. So let's push it using the push function, right? So let's push it. Now the opening bracket is pushed into a stack. Now if it is a closing, now we need to check for the write the condition if it is a closing bracket. Now for closing bracket we have two conditions. It may happen that there is only one closing bracket, right? And in such situation the stack will be empty, right? So now there will be only two conditions for closing bracket, that is it may happen the stack is empty, right? Or it may happen there are some characters in the stack, and we need to check whether the topmost element of the stack contains the subsequent opening bracket or not. If it contains, then it's well and good. We're gonna move to the next character. If it doesn't, then we need to return an invalid statement, right? So let's check if our stack is empty or not. So you can easily do it by writing dot dot empty function, right? Using the empty function, we can easily check whether our stack is empty or not. So we need to have another condition. Let's check for the is validity. Is valid, right? Here we're gonna pass two characters. The first one is the s of I, sorry, and the next one is the stack dot top. That is the topmost element which is actually present in our stack, right? So let's write a function. So it will be a bool and is valid, right? Then let's pass two characters as chr1 and chr2. Now these are two characters. So we need to check this condition, like it may happen that our chr1 is a chr1 actually denotes a closing bracket, right? So it may have, so we may have a closing round bracket, right? In such situation, the chr2 should be a opening bracket, or it may happen like our chr1 is a closing curly bracket. In such situation, we'll be having this. Sorry, it will be chr1, right? In such situation, we'll be having our chr2 as the opening curly bracket, or it may happen our chr1, so it may happen our chr1 is a yeah. Let me just change the size so that you guys can see. Now I think you can just show, right? So it may happen that that our chr1 is actually a closing square bracket. In such situation, our chr2 should be opening square bracket, right? So if either of these conditions is true, then we're gonna return true, right? So if either of these statement is true, so we're gonna return true. Now let's return false if none of this statement is true, right? So if this is valid statement is false, right, then we need to return false, right, because it's invalid. And if neither of these conditions are true, so we're gonna pop the element from this tag, right? So now let's now coming out of the loop, we need to check whether our stack is empty or not. So we need to check stack of empty is equals to true or not, right? Now let's run this code. So upon running this code, we found it has given an accepted solution, right? Now let's discuss time complexity for this algorithm. Now the time complexity will be bigger of the length of the string, right? Because we are traversing through the whole string. Let us consider n to be the length of the string, okay? While the space complexity will be equals to the length will be equals to the size of the stack, right? And hence O of n is going to be a space complexity. So that's all for today. If you like this video, do give a thumbs up to the video, share it with your friends, and don't forget to subscribe to the channel and press the bell icon in order to get the latest notification first. So I will see you in my next video.